Welcome back, everyone. So this is the CI morning at XDC, in which every talk is about automated testing. And I'm going to talk about a testing tool called OpenQA, which I discovered a few years ago and have been using quite a lot. This is my first XDC. It's very nice to be here. I'm very well organized, so thanks to everyone organizing. I'm a software developer at Codethink, which is a consultancy firm based in Manchester. And I've also been involved in GNOME for quite a number of years. And actually, my interest in OpenQA comes from the combination of these things. We've been using OpenQA in Codethink to do testing on various customer projects and some open source projects. And as part of that, I've been looking at using it in GNOME to test the GNOME OS, which is like the testing-only distribution, which aims to break all the time. So we find the bugs before distributions find them. This is quite a technical audience, so I'm not going to spend any time telling you why testing is important. But end-to-end testing is very important. Historically, we've wanted to do it, but it's just been too difficult. So we're like, okay, I can unit test this bit, and then I can mock this thing, and then actually, when it comes to testing the system as a whole, it's too difficult, so we do it manually. And I think we're just entering the era now, as you can see from the previous talks as well, where we finally have the technology and the time to do proper end-to-end testing, where we build an operating system, deploy it on a device, and check, does it boot? Okay, and we can now do that automatically. So integration tests are very important. And OpenQA is a tool for testing operating systems. So the key features are it controls either virtual hardware or real hardware, and it's specifically optimized for screenshot testing. So if your device has a screen, it can be useful. If it doesn't have a screen, you can still use OpenQA, but maybe it's a less useful choice. It's a project developed since about 2008, I think, mainly by SUSE. And I think still most of the funding for the maintenance comes from SUSE. So thank you, SUSE. I hope we can add more companies to the list. It's open source. It's nice to contribute to. The maintainers are friendly. And it's one thing to be aware of, it's released in a rolling fashion. So you just use the latest version. There's no like 1.0 or 2.0. It's like, okay, you have the current version and then some old versions. And like I say, the main idea is doing screenshot testing. And it has a couple of features to make that easier. So it doesn't just compare pixel by pixel. It uses OpenCV, and it can match like one specific region of the screen and match against a threshold. So, okay, this is 90% the same as the last screenshot, so we'll say that's a pass. And it's written in Perl, which is very exciting. If you grew up in the 90s like me, then it gives you a nice sense of nostalgia. But actually, the code base is great. It's very easy to read. It's very concise. So although you might have to remind yourself how to write Perl, it's not a problem at all to contribute. So I'm going to show you, let's start from a demo, and then I'll explain a bit what's going on. So for the testing I've been doing of GNOME OS, I've been running the tests locally on my laptop to develop the tests. It's the most convenient thing. And this involves running the OpenQA test runner in a container, and then the container spawns QEMU, and that boots the operating system. So the tool I'm running is a small wrapper around Podman, which starts the tests and then talks to the control socket to pretend to be the web UI. So it makes local development a bit more fun. And it's also, this tool is written in Rust, so it's even more fun. So the tests are running. You can't see anything, but if I pause them, I can get this command. Let's start the tests again. Okay, so they're back running. And now here, I'm going to connect to the VNC connection that's running on the virtual machine. So actually, this is what's happening on my laptop right now. It's stepping through the GNOME OS installer and creating a user. This is a view-only connection so that I don't break the tests, but you can also, if the tests have already failed, you can use VNC to go in and debug a bit about what's going on. So it's going to start opening the apps, etc., etc. So let me explain a little bit more about how this works. Okay, that's what's actually going on to run the test runner in Podman. So there's no magic. The reason I'm doing it in Podman is because of the rolling release versioning, right? So OpenQA is packaged in distros, but I don't think there's much maintenance of old versions. So I prefer using the container because I know that's the latest version. And if I find a bug, then I can fix it upstream rather than saying, well, you're using this 4-year-old version that your distro packaged. So what you basically do is you need an operating system image and various other assets, which might be a kernel or some data that you download during the test. You need some tests and needles, which are basically screenshots. The test runner is this thing called ISO to video. And first it creates a machine. So here it's created a virtual machine in QEMU, but it can also manage hardware using different backends. So the machine could be a device, and you write a shell script that boots the device, or you use IPMI to boot the device. And then the machine will provide one or more consoles. Console isn't used in the way you might expect. Like a graphical display is a console. The serial terminal is also a console in OpenQA terms. So depending on what the console is, you might send a string if it's a serial terminal, or you might send mouse clicks and key presses if it's a VNC connection or a VirtIO device. And then screenshots come back to the test runner. The test runner is the thing that checks if they're correct. So the test runner will, not the device, but the test runner will look at these and go, this screenshot matches, continue. This screenshot matches, continue. This one doesn't match, you fail. And at the end, you get some test results, which are the pass or fail. You get a video of what happened, all of the screenshots it captured, as many logs as you want to save, basically anything. So that's fine for local testing. Let's see if this finished. It didn't finish, actually. So I'm going to talk about how we're using it in CI, because local development is fine for developing the tests, but then you want to automate these things. That's the goal. There's two approaches to do this. The way openSUSE do this is OpenQA manages everything. So the workers are persistent, and they have some sort of infrastructure team maintaining them. And OpenQA is responsible for scheduling out jobs. So you submit a job, you say, I want to run a test, and it will choose a machine and run the test on that machine. That's one way to do it. In GNOME, we decided to do it a slightly different way, mainly because we have very, very limited sysadmin resources, and we don't want to add a whole farm of machines to maintain. So what we do instead is we start a test pipeline in GitLab CI. That builds GNOME OS, and now we have an OS image. And then we have another job which starts the OpenQA worker in the container that is the GitLab runner, registers itself with OpenQA, and then says, I want to run a job, it's this job. And then the GitLab runner becomes the worker. So it's a slightly more complicated approach, but it means we don't have to maintain GitLab runners and OpenQA workers. We just maintain the GitLab runners. And for virtualized testing, that works really handily. But what if you want to go beyond virtualization? I realize there's a lot of driver developers here, right? So you're thinking, well, virtualization isn't actually what we do. So I'm going to jump ahead a little bit and talk a bit about hardware. This is the real world of testing on messy bits of hardware, right? So in Codethink, we've done quite a bit of experiments with using OpenQA to test things on hardware. One thing we've done in the open is this pipeline which tests the mainline kernel on various boards that we have in the office. And we set this up using Lava. So it's a slightly more complicated setup. We have GitLab CI doing the build, which pushes a kernel to this TFTP server. Then we use Lava to deploy a board, as in it flashes the image, boots the board, runs a script, and then the script does the same trick as before, that it will tell the OpenQA server, hey, I'm a worker, I want to run a job, it's this job, and now the job runs on the device. Again, there's multiple ways to do this. You can have OpenQA managing all of your boards, or you can do it this way. Kind of up to you. And we can see some examples of this if I change the tab. Here's a test which ran on aforementioned unmatched board. So the screenshots are fairly simple here. Did it boot to Ubuntu? Yes, so a lot of things worked. Does it have a hippo? Yes, so all good. And then it runs a couple of checks on the serial console as well. This is the OpenQA web UI, which I think I'm not going to have too much time to talk about, but I'll quickly show you the kind of stuff you can do. So when the tests run on, if they're not running on your local machine, you have a real OpenQA server set up, then all of the logs also get uploaded to the server, and you can visually see what happened. So here's the GNOME tests, and here's one that failed, right? So this is the web browser, and this is the screenshot we got to the device, and it says 52% match against the expected screenshot. So what was the expected screenshot? Okay, we can drag from left to right. On the left is what it should be, because it should have this welcome message, and on the right is what we got, which doesn't have a welcome message. So you have a UI to go exactly into what's the difference, what went wrong. Here we can immediately say, okay, what went wrong is this widget didn't show up for whatever reason. This is the main reason you would use OpenQA, I think, is that you get this cool web UI, which means even sort of you don't need deeply technical people to maintain the tests. You can have QA engineers saying, okay, this screenshot, I want to update it. There's a UI which you can open in the browser to update the screenshots. And it works very well. So I think I'm almost out of time. I wanted to talk a little bit about some further hardware experiments we've done at Codethink. These are a little bit unrelated to OpenQA, but I think they're interesting. So a lot of the work we've done for customers has been on car systems. These don't have VNC or VirtIO devices. So we developed this really lightweight remote control system that is a static binary called QAD. You run it on your device, and you can use HTTP requests to inject input events and capture the contents of buffers. That's available on GitLab if that's something that's useful. And we developed some hardware devices as well. So this was the first. It's a bidirectional USB switcher, which is really useful if you have tests involving plugging in a phone or plugging in USB devices. Previously, we'd have people spending weeks of their time plugging in USB devices manually. So this has saved some people's sanity. It's not something we're selling at the moment, but all of the schematics are available and the firmware is available at this GitLab repo. So if you know anyone that fabricates devices, you can get some fabricated. And this was such a success that we thought, what if everything was in a box? What if not just the USB switch, but everything was in a nice black box with a Codethink logo on it? So another project which is still in development is this thing we're calling testing in a box, which, as the name suggests, is a box with as many protocols and as we can fit in. A small computer that can run a GitLab CI runner or an OpenQA worker. That's still in development at the moment, and we don't know exactly where it's going to go, but it seems like an interesting idea, and there's a lot of people thinking about these problems at the moment. So I think I'm out of time. That's all I really had to say anyway. Thanks for listening, and we have a minute or so for questions. Or maybe more, actually. I'm not sure if that was 1 minute to talk or 1 minute for questions, so maybe we have more.
Thanks for working on this. I was wondering how you handled performance variations between DOTs or test machines. So when you were showing the video that was installing SUSE, so do you capture the output and then check for a certain state as a way to transition to another state? So can you talk about it?
Yes. So maybe the easiest thing is if I just show you the code of one of the tests. Because it's pretty simple. Basically, it's using timeouts. So if we look at that GNOME welcome test that ran, the way an OpenQA test actually looks is this. So there's a test API, which is a series of Perl functions. And the main thing you do is you assert, this is the tag for a screenshot, and you give it a timeout. So it will continually try and match until the timeout runs out, and then it will fail if it didn't match within the timeout. So in order to account for performance variations, there's nothing sophisticated. You just have to magically get the right timeout value through trial and error.
Have you tried using that for games?
No. No, I'm sure it can be improved. Any more questions? If there isn't, I can show you what you get in the output directory. So once you've run the tests, you get various logs of the test runner, and then all of the screenshots and some JSON metadata saying which bit matched and which one didn't. So the web UI uses this to say, to render that slider of, okay, this part matched and this part didn't. But you can also use the raw data if you want. If you run serial commands, then it gives you a text file with the output. And then the coolest thing, this is the thing that always impresses people, is it gives you a video of what happened. So after the fact, you can see a whole video of everything that we saw in the test, except it's sped up a little bit. So that can be a nice thing. Any more questions? Or have I explained it perfectly?
So you said you take contributions?
Yes.
Okay, cool.
Yes, so OpenQA is not my project, but it's a very friendly project, mainly run by SUSE. And then I don't know, which bit are you more interested in?
Oh, this would be for performance testing of games.
Okay, yeah.
But yeah, are you like married to Perl, or can we just agree on a YAML format?
Yeah, so
move away from this.
Like I say, I didn't create OpenQA, and I wasn't there when the decision was made to write it in Perl. I'd say fundamentally it is going to remain Perl, but the good news is it's quite componentized. So, for example, you can use the web UI as is and re-implement its API in something else. So you could have your own worker implementation written in a language that you like, and that could still integrate with the web UI. I think that's the direction the project should take. I'm quite one thing I'd like to do is organize a hack fest where all the people interested in this get in a room with the people working on OpenQA. Hopefully something to do next year, so I can keep you in the loop about that if you're interested. Okay, no more questions. I think we're done. Thanks a lot for watching.